Listed below are the systolic blood pressure measurements obtained from the same woman. Find the regression equation, letting the right arm blood pressure be the predictor variable. Find the best predicted systolic blood pressure in the left arm, given that the systolic blood pressure in the right arm is 100 millimeters. Use a significance level of 0.05. Okay, first, let's go ahead and run a regression and find this equation. So I'm going to click Open in StatCrunch. Okay, let's go to Stat, Regression, Simple Linear. Okay, it does say use the right arm be the X, so I'm going to let X be the right arm, left arm is Y. I'm going to run the hypothesis test and press Compute. Again, let me look at the graph. Doesn't look great, right? We got one guy right here that's a little bit off. So I'm curious what happens here. So we're given the equation here. Let's come down a little bit. Around to 1 decimal place is needed. So it's going to be 58.9. And then 1.1. And that is a plus. Okay, don't want to miss that. Okay, now the problem says, given the systolic blood pressure in the right arm is 100, the best predicted systolic blood pressure in the left arm is what? So the question is, can I use my equation? So we look at the p-value for the slope. So looking at the p-value for the slope is 0.07, and they're setting this significance level at 0.05. And we cannot use this equation. If this is greater than 0.05, we cannot use the equation, and all we have to use is the mean of my data. So I'm just going to go to Stat, Summary Stats, Columns, and I'm just going to find the mean. Really, that's the only thing I need. And the mean is 157. So the mean of the left arm, 157. Again, if that p-value had been lower than 0.05, I would have used my regression equation line and put 100 in for x. But it wasn't, so I can't use that regression equation line. Now, I'll be honest, you really don't even want a regression equation line if it doesn't accurately model the data. But this is the order in which they put these questions, so let's just go ahead and go with that. Okay, so again, they give you a table here of critical values. So you can go ahead and find the R value. We did that with StatCrunch, and then compare that R value in here. So we had an N of 1, 2, 3, 4, 5. And you can compare the R value at 0.05 to, in this case, to 0.878. And if the R is greater than that critical value of 0.878, then you can use the equation. But it's not. Our R is 0.841. So that's another way to do it using the table. That's generally not the way I do it. I will go ahead and look at the p-value. It's just one less thing for me to think about. I know what the p-value means. That p-value is too high for me to be able to use my equation. So I hope that helps. And you would do this exactly the same way on the TI. You would go ahead and run the statistic. So you would run the linear regression t-test. We've done this before. I'm not going to do it for you again, but you just go to stat test, and it says F. You would put the data into L1 and L2 and run it. And then look at that p-value. Or if you prefer, you can look at the R value and compare it to the critical value here. So I hope that helps.